Welcome everyone. In this video, I will walk you through my file encryption and decryption project. This project is designed to securely protect files using modern cryptography, while keeping the user experience simple and practical. The idea behind this project is to give users two different ways to encrypt their files. One option is a desktop application that works completely offline and uses a password chosen by the user. The second option is a web application that runs in the browser and performs encryption on the server for convenience. Both versions are built to handle real-world use cases, support common file types, and follow strong security principles. Throughout this video, I will explain how each application works, what technologies are used, and what the benefits and limitations are. Encryption is the process of converting readable data into an unreadable format. Only someone with the correct key can convert it back into the original form. This protects files from unauthorized access, even if they are copied or stolen. In this project, encryption is applied at the file level. This means any type of file can be protected, including documents, images, videos, audio files, and archives. Let's start with the desktop application. The desktop application is designed for maximum security and privacy. All encryption and decryption operations happen entirely on the user's machine. No internet connection is required, and no data is ever sent online. When a user wants to encrypt a file, they enter a password. This password is never stored anywhere. Instead, it is converted into a cryptographic key using a secure process called key derivation. A random salt is generated for each file. This salt is combined with the password and processed using PBKDF2 with the SHA-256 hashing algorithm. This makes brute force and dictionary attacks much more difficult. The derived key is then used to encrypt the file using AES-based encryption through Fernet. Fernet provides both encryption and authentication. This means it not only hides the contents of the file, but also detects if the file has been modified. The encrypted file contains the salt along with the encrypted data. This allows the file to be decrypted later using the same password. When decrypting a file, the application reads the salt from the file. It then derives the encryption key again using the password provided by the user. If the password is correct and the file has not been tampered with, the original file is restored. If the password is incorrect or the file was modified, decryption fails safely. No corrupted or partial data is produced. The desktop application is optimized for performance. It supports multiple files in a single operation and can handle large files up to 100 megabytes per processing session. The user interface is built using Tkinter. It includes a file picker, password input, encrypt and decrypt buttons, a progress bar, and a status display. Files are processed in memory and are only written to disk when the user chooses to download them. This improves both security and user experience. The desktop application is best suited for sensitive data, large files, offline environments, and personal backups. It gives full control to the user and does not rely on any server or third-party service. Now let's talk about the web application. The web application is designed for convenience and accessibility. It allows users to encrypt and decrypt files directly from their browser without installing any software. Unlike the desktop application, the web application does not use user passwords. Instead, it uses the securely stored server-side AES encryption key. This key is managed through environment variables and is never exposed to users. When a user uploads a file, the file is processed temporarily on the server. The encryption algorithm used is AES in GCM mode. AES GCM provides both confidentiality and integrity, ensuring the file is encrypted and protected against tampering. Each encryption operation uses a random nonce, which ensures that encrypting the same file multiple times produces different results. After encryption or decryption is complete, the processed file is returned to the user for download. The original uploaded file is then deleted from the server immediately. No files are stored permanently. This minimizes the risk of data exposure and improves privacy. Because the web application relies on a server-side key, users must trust the server. If the server key were compromised, all encrypted files could be affected. For this reason, the web application is recommended for quick tasks, small files, and situations where convenience is more important than maximum security. The recommended file size for the web application is up to 10 megabytes per file. Larger files may take longer to process due to network latency and browser limitations. The web interface is designed to be simple and user-friendly. Users can select files, choose whether to encrypt or decrypt, and download the results in just a few clicks. The web application works on any modern device, including desktops, laptops, tablets, and mobile phones. Now let's compare the desktop and web applications. The desktop application uses password-based encryption and works entirely offline. It does not require trust in any server and is ideal for sensitive data. The web application is online only and uses a centralized encryption key. It offers ease of use and accessibility but requires trust in the server. Both applications use strong AES-based encryption and include tamper detection. Each application serves a different purpose, and users can choose the one that best fits their needs. This project uses several technologies. The desktop application is built using Python, Tkinter, and the Cryptography library. The web application is built using FastAPI, AES GCM encryption, and a browser-based frontend. Security best practices were followed throughout the project. Passwords are never stored. Keys are managed securely. Files are processed in memory whenever possible. There are also areas for future improvement. These include adding a password strength meter, implementing streaming encryption for very large files, and introducing rate limiting for web uploads. Zero-knowledge encryption for the web application could also be explored, though it would significantly increase complexity. In conclusion, this project demonstrates how modern cryptography can be applied in both desktop and web environments. It balances security, performance, and usability while clearly explaining the trade-offs between different approaches. Thank you for watching. If you found this project useful, please like, share, and subscribe for more content like this.